Okay, we're going to use a data file and arrays again. And this time we don't know exactly how many offices are actually in the data file. So we work with one of those conditions where we don't want to go outside the array, and we also want to make sure that we read as much of the data file as we can without going over the array. And if the array is larger than the data in the file, then we should read all the data in the file. So we have an array of size 12 and we only have 12 offices. We happen to know that the array is not going to be completely filled. And in the previous program where we have 12 and 12, we used a for loop to run through the array, and we could do that because we knew the size of the data. And over here with 12 offices and an array of 20 is a situation where you don't necessarily know the size, so you need to use a while loop to get all the data. Now if you look at the condition on line 27, it says that while the data fits in the array and you can read some data from the file to the array, and you see that over here in 27, while the count, which is the index of the array, is less than the size of the array that we have defined over here, and we can still read some data from the file into that array. Just for fun, we do something a little bit different with this program. Instead of calculating first the total, then the average by dividing the total by number of offices, and then running through the array and finding the maximum and the minimum, now we're going to use the average to generate an exception report. And an exception report is where we only report special cases. And in this case, we calculate the average sales and then list only the offices with below average sales. So as usual over here, let's put our constant over here at the global level. We have over here our num offices, and we now need to keep track of how many data points we have. So we're just going to count them as we go along. And then over here we have our array with the sales, the total sales and the average sales. We don't need the min and the max. Same thing over here, open the same sales.dat data files that we had before. Remember that we increased this a little bit, so we would get a nice round number for the total. We're going to read again, and since we're going to count how many data points we have, we start with 0 over here, and now over here we have our condition where we want to make sure that that the count is not going to go higher than the size of the array and that we can still read something. We add the new data element that we find to the total sales, and we increase the count by 1. So then we say num offices is count. Because we also have the possibility that we have fewer than 20 data points, and we close our data file over here. Calculate the average sales again, we do need that. We report over here the total sales and the average sales, and then over here we print a listing of offices with below average sales. So we start with the first element in the offices array, go up to the num offices but not including, one more at a time, and then only if the sales for that particular office is less than the average sales, then we're going to print this over here with its actual sales figure. So here we're going to run that. So you see that we have a nice round number here. This is the average, and this is 749, 624 less, 534 less, 356 less, 435 less, 456 less. So at least for these numbers it seems to be working. And notice that we only have 1, 2, 3, 4, 5 out of 12 offices that are listed here. Just for fun, let's do this. We're going to make this number much larger. This will really push up the average, and we know that the last one has a really high average. So let's see how many offices are now listed. And look ahead, look over here. All offices are well below the average now. Even this one over here, because the average is now almost 9,000 bucks, and the highest sale over here was 1,200 bucks. Let me take this back. Okay, that's it for this one.